Good morning, everyone, and welcome to Team 2 of Day 2 at the CitA BIM Gathering Virtual Conference. As you might have heard at the opening address by Dr. Claire Penny, that we're looking today at unlocking innovation to transform industry. So the theme that I'm chairing this morning is new and emerging technologies. And we have three speakers with us this morning. We have William Adams from Felix Hore Limited, Northern Ireland, and Tara Brooks from Queen's University in Belfast. They'll be doing a sort of a joint presentation. We've also got Alain Waha is back, and Alain will be giving us a sense of the digital tool chains for modern methods of construction and the construction innovation example in the UK. So I'm your host for this theme, Alain Hore from TU Dublin and the Construction IT Alliance. So I think we might start with our first presentation. And can I just remind all our viewers to encourage you to put your questions into the chat facility on the right-hand side of your screen, and I can have a look at those as we approach the Q&A. Thank you. So over to you, William.
Okay, everyone. Actually, I'm going to start off. I'm Tara Brooks from Queen's University. I am absolutely delighted to be here with you just to introduce the project where William did 95% of the work. So he's going to be doing 95% of the presentation to explain it. So this project arose out of a KTP, a knowledge transfer project, which is a UK government industry academia partnership. It's a three-way partnership between Queen's, Felix Hore, and then William Adams, who was a really important part of this. He was the KTP associate. And this came about by Felix Hore thinking that they had these quite sophisticated BIM models, but they weren't really exploiting them to their fullest extent on site. And that was the original aim of the KTP project. So I have to again give credit. I wasn't the only academic supervisor. I was also joined by John Maneely, who is an expert on drones, laser scanning, and the kind of technology that's been used in this project. So again, I just want to give credit to Felix Hore, who were very innovative and forward-thinking and really keen to experiment and to try to innovate during this project, and to William, who is absolutely key to its success. And also maybe just to say, if anyone's interested in doing something similar, there is a kind of sister program called Fusion Projects, which are between an academic in the north and a company in the south. If anyone's interested, my email address is down there. Please get in touch. So I'm not going to talk for much more. I'm just going to hand over to William now.
Thanks very much, Tara. So just an introduction to myself and Felix.
Felix Hore.
Is that better now? So Felix Hore are based in Dublin. They're building contractors and services include pre-construction. Sectors of education, healthcare, and leisure, transportation, and conservation works. As for myself, I completed my master's in project management and BIM in Queen's there and just graduated at the end of last year. And in terms of drone license, I received that in May 2019 through the KTP program and as part of Felix Hore development into drones. So as part of the adoption of BIM and digital construction, we've seen the potential for their benefits. And over the past 2 years, I've been trialing different software use cases of drones and really working with all the staff in Felix Hore, both on site and in the office, to see what works best for them and their workflows. So hopefully I can provide everyone with a bit of experience, what I've learned over the past 2 years in order to help if you're hoping to implement or fully take advantage of drones within your practice. Also, it's a bit of validation for myself that I'm not just out inside playing with little toys all day. Yeah, so in terms of the adoption of drones, The global drone market is projected to grow from 3.6 billion euro in 2018 to 36 billion euro in 2023. So it's 10x in a 5-year time span. Also, research from Barclays suggests that they're going to save 85 million euro because of this year adoption. I wasn't able to find any research completed within Ireland specifically, but figures from the UK give an idea of the growth in the industry. So the Department for Transport reported that there'll be approximately 90,000 drones in the UK at the minute, and predict between 200,000 and 900,000 drones by 2050. Just in the graph on the top there. Although in the bottom here, PwC issued a report in 2018 saying that there will only be 76,000 drones in the UK by 2030. So there's a bit of discrepancy there in numbers, so I don't know what to believe, but yeah, there's 4,800 drones projected to be in construction, which is about 7% of the total drone market. Also, in construction, the NBS reported that there was a 58% annual increase of drones within the construction industry between 2017 and 2018 in the UK. And with the pandemic, it said that the adoption and utilization has only increased. As well, there was a report done by Drone Deploy in 2018. They're an American software company and believe construction is a fast growing sector in terms of drone adoption, with 239% year-over-year increase from 2017 to 2018. They also highlight that just over 60% of construction companies were using drones for progress tracking and communication. Then there's a steep drop off before any other uses in terms of site planning, quality assurance, use for tenders, and lastly, job site risk mitigation, really health and safety. In terms of the type of drones, there's two main types of drones with practical benefits within the construction industry at present: multi-rotor drones and fixed-wing drones. So multi-rotor drones are your typical rotational propellers, and the most popular is your quadcopter. As well, you can get a multi-rotor carrying higher pitch items such as high quality. And most commercially available quadcopters are 20 to 35 minute flight time. So really sufficient enough time to go around any small to medium construction site. Then we'll have fixed wing drones, which have greater stability and higher wind conditions because of the aerodynamics that they have. Also, because of this, they can travel longer distances. Some commercially available fixed wing drones covering 5 kilometers squared in 90 minutes and within one battery. They require pre-programmed flights, which are completed autonomously with no manual interaction required, and the onboard camera remains in a fixed position. So there's no manual tweaking once the flight takes place. So this needs to be considered before taking off. These are primarily used in large-scale projects such as corridor modeling and road construction. So just get into the case study a little bit more for the benefits realised using drones within Felix Hore. So initially, as shown in the drone deploy research, the most obvious benefit of drone use is on-site progress tracking and monitoring. So this has gone from monthly images taken on our construction projects to weekly on some of our key projects, and really that there depends on the project team requirements and the type of project that we're working on. If all the information we collect from the drone data is uploaded onto our common data environment for the entire project to view, so everyone has an idea of what is going on at any stage in the project. And we've seen great uptake in this here for use through the whole project team, including clients requesting it and getting great satisfaction seeing the progress of the project. It allows them there to be more engaged. And on this here project below in particular, the contract manager said that they have found program efficiencies through unique perspective on images provided using drones that wouldn't otherwise have been realised. Although from me trying to quantify this here benefit, it's very hard to say exactly how many weeks or days that using this here drone information that they've been able to save on the project. This here slide shows an example of the use of drones for logistics planning used in the project. The image was imported into Revit, which was the modelling software on the project. And here we were able to identify the radius of crane to show the optimal position and what was needed to avoid double handling of blockwork, and measured to ensure plant could get past in this here tight site. It provides better visual for the site conditions in comparison to plan drawings which were previously done, or sketches. A third sort of benefit we have seen within Felix or Hore is images frequently used for health and safety officers for works plans and health and safety reports. Below in the image here was just in response to COVID, we outlined our site setup with hand sanitize stations and walkway systems and everything, and give everybody on site a better indication of where they're going. The weekly imagery also provides checks for working at height, ensuring harnesses, PPE and scaffolding inspections are all in place, as well as checking for clearways and materials are stored properly to avoid slips, trips and falls. Thermal imaging has also been adopted within drones, mainly for search and rescue uses, but within commercial drone construction, it's found that thermal imaging cameras can be utilised to identify leaks in the building envelope, heat loss and defective materials through the difference in temperatures is able to be produced from these here cameras. And it provides instant validation and data on the build structure. Therefore, any defects can be corrected in a timely manner. So moving on from basically just standard images, photogrammetry is a process where two or more overlapping images taken of an area or object or process, and the difference in perspectives from each image provides enough information for the software to calculate the distance from the camera to the ground through triangulation. And this can generate a 3D tie point, which is a coordinate on the ground, and it's used through contrasting pixels. The programs that provide automated flights in order to get better overlapping and more accurate dimensions is Pix4D, Drone Deploy and Lychee. And three main factors that impact the result of the density of the point cloud include the resolution of the camera that's taking the pictures, the distance from the camera to the object, and the quantity of overlap between images being stitched together. So obviously the more images, the better quality, but then the more processing and everything has to be done. So softwares really that can do this here is three main ones that I've found that are used within construction are Pix4D, Drone Deploy and Capturing Reality. And one of the main sort of benefits used from photogrammetry is orthographic images. So in the image in the top right sort of gives you an idea it can generate a plan view which can be used for management of length and area on site, and it removes the warping or perspective view that standard images provides. It can be seen, as the images are stitched together, a large area can be captured within the one image, and this results in better and more accurate logistics and site management plans, just captured in the full site. You can see here the difference between a standard image taken on one site compared to the ortho-rectified image we produced from that. Also from photogrammetry, we can calculate volumes for bulk dig to be exported off-site. And this can be done within the web interface of drone deploy software or Pix4D. As well as reports, which can be compiled within the web interface and distributed to the team without any other software, such as areas of interest, planning, storage compounds. You can see highlighted here in orange and purple, just highlighted areas where materials might be stored or next phase of works. Also on the right, image here, we extracted contour maps from the photogrammetry process. And here we used to calculate the volume difference before and after the bulk dig excavation of this here project. And on this here, we find that there was a difference of 20% between the volume calculated by the QS and the volume from the drone. From this here, we find that we did not calculate for the bulking factor of the soil, as well as material being imported to site, and plant and materials that are being stored on site, as well as fill that was transported to the site for a later date. So really, we've learned lessons from this year that taking forward to the next project, that we need to account for activities and what's going on the site as well. But comparing this here to the results from the site engineer, they did a manual takeoff using their GPS and total station, and there was a difference of 35 meters cubed over a 7,500 meter squared site, which is a difference of four lorry loads of material being exported. So really we can see that the calculations were correct. It's just accounting for everything within them. Yeah. Final benefit from the ortho-rectified image is for validation. So this is a new feature within Drone Deploy, which I find very useful. We were able to import drawings into the web interface and overlay them on the resulting photogrammetry. This image, we overlaid the piling drawing over the site to validate the installation of piles, and you can see here the mushroom caps with yellow dots centered on each pile for precision of piling. So I find that they're very beneficial, and it's great as a quick check, really. And finally, we use photogrammetry in a test against laser scanning in a building for validation of structural components within a building. The laser scanner used was a Faro Focus AS150. It took approximately 1 hour in total to collect and upload drone data for processing to generate this 3D model, as opposed to 4 hours on site with the laser scanner, and an additional 2 hours for processing and exporting the data. As well, we had to stop construction workers several times in order to scan a certain section of the building. This is a sort of relatively small site, so if it was over a larger site, you can see where the benefits are. So within the two images here, I think you can see the difference between the quality of the images. The bottom is the photogrammetry output, and the top is the laser scanning. Due to the slenderness and the slim profile of structural beams and columns, it takes a lot more data than we initially realized and captured on site in order to define
and validate structural components using photogrammetry. I think on this year test, it was 160 photos taken of the entire construction site. So a relatively small number. Whereas, laser scanning, you're able to get down to 5mm accuracy, and you can be pretty confident in that there. However, with photogrammetry, large surfaces really work well, as it provides more type points in the software. So from this year, we find that photogrammetry, we can use this year for validation of services for civil services, concrete framing, and really facades or any external components, apart from slender structural. So we know that there, and going forward, we can say, oh, we want to validate this year and this year. Then we need to use this year to either bring in a laser scanner or just use the drone. So I believe this is where photogrammetry comes into its own, where the data can be shared on the web interface as opposed to exporting and importing the data, such as point clouds, which require specific programs, which contracts managers and site engineers have no time for or need to be installing. All the information can be accessed by all parties within the web browser and interpret all the data that they need. Also, it's just not the single 3D model output that we get from the drone data. It's everything, the combination of all these here outputs from topographical surveys and with rectified images, and how this here ties into all the activities on site, and really find the benefits of this here photogrammetry process. So in terms of the future of drones, I think this here sort of common is the use of 5G and connected drones. It may allow live feed recording of drone images to anyone that is requiring live site data for inspection, such as health and safety authorities, or back in the office, any urgent information that needs to be relayed to site or back to the office again. These 5G into drones, I believe, can aid this year, as well as better communication between other aircraft and their unmanned aircraft to intelligently avoid each other, streaming real life data. And in terms of autonomy, I believe we're sort of at a level 3 stage at the minute, where many flights can be autonomous. However, they always require a pilot there, and other factors, as well as being able to complete the mission. The main impact this year is charging the drone, the weather conditions, and whether or not the drone is able to adapt to these here, as well as site obstacles. So plant and machinery and people moving across the site all the time and changing. This year really needs to plays a part in all this year. Yeah, so as well as setting out and LiDAR scanners, these here attachments, and other drones really going forward can provide further benefits on site. So if you're interested in getting started in drones, where you begin really, I think it's best to identify if there's someone within your organization that would be best suited for the role. If it's outsourcing, if it's on a more infrequent basis, even to start, ideally you want someone that knows a bit about photography. Also helps a lot when on site to capture good images. You need to set a budget for the upfront costs, as well as any recurring annual costs that are associated with drones, such as licensing, subscriptions to services such as video editing, photo editing, and photogrammetry software, as well as potential maintenance of the drone. And there's always potential for a crash. So you need to take that into consideration. Also, what type of drone do you need? Camera quality, size, or thermal imaging requirements. Yeah, really, I think it's incremental stages. Yeah, so thanks very much, everybody.
Thank you.
Any questions?
Thanks very much, Will and Tara, and well done, Will. You know, it wasn't easy to deal with that transition there in the middle of the presentation. I did say yesterday, we're not machines, we're human beings. and we have to deal with these issues as they come along, but well done. I got a great sense of what the importance of drones. I can see the positivity that they bring to the construction process. I'm sure there'll be a number of questions for you, so we'll come back to you on that. So to our second speaker, and the delegates may notice this morning our presentations are a little longer because we have 2 core presentations, not 3 in the stream. So Alain, very welcome again. You're going to tell us all about the digital tool chains for modern methods of construction. We heard about the importance of delivering housing in Ireland, and maybe this is something you could touch on.
Yes, thank you. It's great to be back, and yeah, this is more of a share out and a conversation, and indeed, I think it's highly relevant in terms of how we might use industrialized construction to deliver, for example, housing at scale. And what I want to share is the work that's going on in the UK, and that's being spearheaded through the Construction Innovation Hub. And you'll see it's a massive teamwork. So I'm just a spokesperson here, and I come at it with the digital angle, and in the term of this conference, how BIM is then connected to this, and how we use BIM to really unlock a number of things, and really will focus on the unlocking part rather than the business as usual digital construction. The focus of the Construction Innovation Hub is to bring manufacturing thinking and digital thinking to the construction industry, with what I term accelerating industrialized construction. And this is a bit of a share out of work done by Grimshaw Architects and their digital team, Maze Construction, their digital team, and Burrow Happold, our digital team. And so I think it's important to set the scene first. What is it? So the people that gave you BIM level 2, that's the UK Infrastructure Project Agency. And so there are the people that sit in government and say, how do we encourage, enable the construction industry to operate better? And the central hypothesis, which I think has been well presented now, and I think it is important that people read this, and it was published last Monday again. So the Social Infrastructure Roadmap Delivery 2030 from the UK, which says, you know, we're going to get digital and we're going to get industrialized construction to work in the UK. And central to this topic is the concept of platforms. And so the hypothesis is that if we use platform construction systems, we can deliver infrastructure at scale. So not just we'll manufacture a few buildings, we'll try to manufacture a large percentage of the building. That was the hypothesis against which the UK government started to invest, and which we're working on. And what's been stood up, and I'll just take a few moments to explain, because government says, you know, we have a housing crisis, or government says, you know, we're still late at delivering schools. What can we do about it? So here we've mobilized a 3-year program with 70 million plus funding to accelerate the convergence of manufacturing. And this was called the Construction Innovation Hub, that sits in Coventry, and it's a conversion of the Centre of Digital Build Britain, that talks digital, the Building Research Establishment, BRE, that thinks construction, and the Manufacturing Technology Centre, which is a research establishment that tries to accelerate advanced manufacturing techniques. So they came together and says, if we get our heads together, we can get a new construction ecosystem in place with industry. And this diagram tries to show how by combining, you can see at the heart, a physical output, the building, a digital output, this digital twin, and then that is being delivered and producing outcomes, a strong focus on outcomes in terms of social. You don't make a school because you want a building, but you use a school because you want to educate, for example. So that has resulted in quite an extensive partnership being set up between the client side, so Department for Transport, Department for Education, Ministry of Justice and the like, and industry. So really quite a big movement here to try to industrialize at scale. Can we manufacture buildings? And so the first part of the work that's been going on is now published. He said, well, what is it that you're trying to manufacture? And if you say buildings, is a little bit unspecific. So we've done a lot of work around understanding that actually buildings are made up of spaces. And although a hospital might look very different from a school, when you think about it at space level, things start to repeat. Toilets are toilets, kitchens are kitchen, reception area are reception areas. So if you can say, well, actually, I'm not trying to buy a hospital, I'm buying so many operating theaters, so many rooms, so many reception rooms, so many offices, so many cafeteria seats, etc., then you can aggregate that amount and start to segment it. So we looked at 35 billion pounds of demand, and we established that if you take the space point of view, then 13 billion of it in the next 5 years is repeatable spaces. The kitchen in the school is the same as the kitchen in the training facility of the Ministry of Defense. When I say the same, I mean functionally and in a regulatory point of view, they are the same, they're a kitchen. It's just that as human and architect, we always start from the beginning and tend to ignore things. So we then said, okay, what is the system that allows you to create this this space? And what's really interesting is that those systems today, they don't actually need to be fixed container sizes. We can manufacture to order, we can configure to order. Most people buy kitchens that are made in 30 and 60 and 90 centimeter cabinets, and it's a system. You don't feel that you are inside a constrained environment if you are in a kitchen, despite the fact that they're all made into factories. So can we do the same trick with facade systems, with ceiling cassette systems, with roofing systems, with partition systems, and then reassemble it? And the answer is yes, we can. And what's really interesting then is that you think in terms of platforms. So a platform is the idea that many clients are going to ask from the market things that are a bit more constrained. So when you buy a light bulb, you can't say, I want a 43 watt light bulb. It's a 40 watt, 60 watt, or 100 watt. Why? Because ultimately that kinds of work. In the same way, you can think about the manufacturing gains you get from that and the market gains you have. So the product platforms that are things like cars. The cars are individuals, and yet they are made out of products that the assemblers of cars are working with their supply chain. They decide quite early on what is it that they're going to do themselves. For example, the shape that you perceive, and then they decide what things that they don't care so much about. Like the brake pads, brake pads are brake pads, and pretty much all manufacturers decide to use the same brake pads. I think what's interesting is to look at the extreme, right? A PC, government is able to buy a PC from many vendors, rarely from IBM. In fact, never from IBM anymore, because IBM sold its PC manufacturing business. So if you've got a entity that governs the platforms that says a PC, what we mean is it can boot. The interfaces are, the PCI slot, the USB standard, the SVGA standards, etc. So if you design this product system, then actually that product system can be totally open, industry-owned, and people can start manufacturing against it, and people can start procuring against it. And then thank God that we've got that for the PC. Otherwise, every single PC that we buy would be redesigned from scratch from the engineers. No, we would have probably something like 100,000 PCs in the world by now. It wouldn't work. They'll be costing billions each, because you design every manufacturing chip, because some architect would make the pin socket for the chip different, because the instruction set of the processor would be different, because the BIOS boot would be different. You couldn't connect the mouse to your PC unless it was made from the single manufacturer, and the single manufacturer would charge the earth for it. You can see the point that you unlock things economically. So very early on, the Innovation Hub started organizing itself. It says, what's our construction system? What are the parts? What's the system architecture? What are the bits of the PC? And this is where that was handed to the digital team and says, this is going to get complicated quite quickly, which means that we can do this for the trivial case of Lego or construction out of containers, but we don't want prisons made out of containers. We don't want schools made out of containers. How can we bring back the context, the flexibility, the agility, the context response? And that's where we started thinking about digital systems that would be able to follow the systems engineering and that would be able to represent those interfaces and these systems. In the built world, actually it turns out to be a lot more complex than the PC world. So this is a very high level representation of how an asset and all the systems come together, and how the fact that we need to define not only what the spaces and these sub-elements are, but we need to hold in mind all their regulatory requirement, the functional briefs and the likes. And so if you turn that for every single element, you start having a lot of cloud requirement and their use, the kit of rules and the kit of parts saying, you know, does it need to pass fire? What's the acoustic performance? What's the sustainability performance? Then turn that into subsystems, subassembly and parts, and then that allows you to create a space. You're not going to manage to do that by hand. And that's where we started saying, okay, those rules are going to be in a rule book. This is going to be a digital rule book, and it's going to be at the heart of a digital platform. So when I talk about digital toolchain for modern methods of construction, obviously first you see that you reintegrate the supply chain into a digital integration platform. Those kind of things are happening in the market today already. You've seen Procore, you've seen Autodesk Construction Cloud. They are more and more connected with the sites through Industry 4.0 cyber physical point of view. So that's happening. That's happening. But what's not really happening is how do you encode the rule book so that the client brief definition, the client can specify a PC. And then that the person that's then planning and organizing and saying, oh, we're going to manufacture this for you, they actually only specify things that are available locally, or don't specify a part that is not compliant to a specific context, a specific regulation, etc. So our industry is quite a long value chain, and so we need to maintain the integrity of the product platform. And eventually then it talks to the offsite assemblers, the product manufacturers, and then orchestrates itself at site in terms of construction. But what I want to focus on is this idea that you need to maintain the rules in check during the value chain. And that's when you talk, in fact, we know about this in the form of configurators. So configurator exists in three flavors. Sales configurator, which is what you have on the screen. Configurator, which are supply chain configurator, post-contract. Somebody says, right, the client has ordered this car. Now let's send that order to all the factories in the supply chain. And then manufacturing configurator, having received an order for a configure to order or an engineer to order piece, then somebody has to actually make it and then sends it, supplies it, and it comes back. So configurator for cars, you've seen them. This is a sales configurator. It only allows you to specify an order that the factory can make and that the factories decided they wanted to sell you. And they actually use this configurator to understand what people want. And so in the construction industry, you've seen this emergence of these automation tools, which are essentially configurator. But all of them do one specific task. So it's not that we're trying to invent something that is not being done already, that you've not seen happening today. The problem is, how do they work together? How does the kitchen configurator actually forces the architect, the interior architect designer to configure the space in the kitchen so that the number of manufacturable kitchen units fit exactly in the space, etc. And this problem repeats. And so that's what we realized we needed to solve first, is to create these configurators that are going to be able to encode the rule book, support it against the user journey of the architects, the clients, the planners, the engineers, and then the manufacturer. What do they want out of these configurators? And then also understand that as much as possible, the complexity and the diversity of the built environment means that the supply chain is not going to be the same. So we understand that they are engineered to order supply chain, modified to order, configured to order, or just selection of variation. So all these types of configurators need to be able to work. And when you are having a configure to order or a modified to order configurator, the configurator then passes a lot of information. Let me just explain. When you do a engineer to order, essentially it's what we have at the moment is the client brief, and then the supply side comes and designs something that meets the brief and complies to regulation. So you just transmit the brief. But if you are doing a modified to order or configured to order, then the client has to specify something that the manufacturing can make. And so what the manufacturing can make needs to be reflected and transmitted back to the specifier. So you've got manufacturing and supply chain aware design configurator. These are the kind of things that we're working on at universities in UCL and in ETH, for example. And so then once you've got that, you still have the problem that those configurators won't talk to each other. So one of the biggest part of the work has been to create a common configurator framework so that all the configurator can exchange information one to each other. So it's not just about BIM level 2 now, where we're saying we're going to try to share models and federate models. We're actually not just going to try to integrate data. We're going to actually be able to integrate rules, constraints, and specification, and exchange those across your design tool chain. So that's now being stood up. A reference implementation has been stood up, and that really supports the generalized flexibility that the tool chain requires. And so that's going to be published, and is being published on open source software, so that anybody that wants to make configurator can then connect themselves into this configurator framework. And so if you are a factory maker, you can create a configurator that's a manufacturing configurator, but that also talks back upstream, so that what you can make can be used and as a constraint to the design. The designer, and they can check, and then go knock yourself, go and build your configurator. So this is the very highest level abstraction of what a single configurator would look like. It has inputs, it's going to produce output, and then you have an interface where the rules and the interactivity actually happen. And we know that out there in the market, you already have thousands of configurator. Bureau has theirs, Grimshaw has theirs, Maze has theirs, and the like. And we believe that that is how we unlock the ability to manufacture buildings that are interesting, buildings that are diverse, buildings that are not only configured to order, but engineered to order, modified to order, that allow to react to the context, the specification, the user requirement, the site requirements, and do that and connect it to a manufacturing industrialized construction base that will make these objects and then allow them to be assembled into useful buildings. So that's what we've been working on and wanted to share.
Thank you. Thank you, Alain. I've got goosebumps, really, because it was a fantastic presentation. what I love about what the UK are doing is that they've got this yes we can attitude. They've got the right people working on the project. They're not trying to eat the elephant in one go. They're breaking it down and they're working together. And that's what I love about the innovation that's coming from the UK. Similar problems. I've got one question, then we're going to open it up. Will the contractors become the manufacturers of the future? The tier one contractors, will they become the manufacturers of the future?
Absolutely. So as part of that engagement, you know, at the beginning, it sounded quite scary. I mean, 2.5 years ago. And I think everybody had to find their place because there's huge amount of knowledge and expertise of the industry that we don't want to lose. You know, we know and love our industry. So the contractor, we now call them an integrator. So the integrator is the one that really, you know, kind of a design and build kind of framework, contractual framework, says, you give me an order for a platform construction system building, and I will make it. And in that sense, is I will configure what I can do with my supply chain. I will then compete on having a better supply chain, access to better products, sub-assemblies, and then execution. You know, I'll have the better site factory.
Yeah, I really hope that the people who are in charge of sort of delivering digital construction and housing in Ireland, you know, either listening to us now, or they're going to listen to it in the near future and take it on board. That's fantastic. We've got a question there, a comment from John White at BRE, one of our sponsors. Out of the work we are doing under CIH, BRE have incorporated BIM tag and tracking into our new standard for modular systems, BPS 7014. Happy for anyone to learn about it. The role of BRE, Alain, you're aware of it.
Absolutely. And again, I'm only a small part and a spokesperson here. You saw the scale of this. So I can't claim that I know everyone and everything that's happening at BRE within this context. But yes, it's joined up. And BRE, you know, and the product, the product as construction product association needs to play a part. And you know, making all these standards come to life, because what's really I think what's really exciting as a vector for progress and digital and BIM adoption is you're trying to assemble a school in 3 days. It's a manufacturing and assembly process. Now that cannot work on pen, paper, clipboards, and
yeah.
You need that digital execution layer, and then that's where BRE is central. You know, they've really worked their digital team, and it's central in many other ways, but their digital team of structuring the information that goes into these systems.
The other comment I made, and I'll come on to Will in a minute, Will, another excellent presentation, but just to talk about the UK approach, obviously it's a larger sector, larger industry, but the money they're investing, 70 million or billion, you know, it's staggering, 70 million funding. And really, you know, I suppose the message to the Irish government, from me anyway, is you've got to invest in the best brains, you know, to get this thing done. And you've got to get the industry much closer to academia and to the tech vendors to make this thing work. So, you know, you spend pennies, that's what you get back. So, you know, that's the big message for me. I also love the idea that the Iron Triangle is there: social, economic, and sustainability. The Iron Triangle, you know, and I can see where all this research is coming together, and you're bringing the best ideas together. Thank you so much, Alain, for that. I'm going to move on to Will and Tara. You know, drone construction. This is just one of the disruptive technologies, isn't it? That's having a positive effect in construction. Could you maybe one of you maybe comment on the you know, the applicability or the functionality of drones to actually resolve disputes?
Yeah, so I know a number of our projects, because we are taking drone imagery once a week, it really provides an accurate record of what's been done to date. It's there. There's no disputing it really. Like that's it. That was part of the progression. So it was because we initially were doing it once a month just for progress reporting, but then we found, oh no, we needed to find out this here information. But it was in between the two dates that within the month really. So then we stepped it up into the
because I trained as a quantity surveyor and then went on to study some law in later years, but there was always disputes with the client about the volume of soil that was excavated from the site. And we still use pen and paper to try and come to close the gap. How sophisticated is this technology now that we can actually measure very accurately the excavation in the solid, not the bulk, because it's the solid that we get paid for as contractors?
Yeah, so point cloud photogrammetry is to within a 50mm tolerance really. So we take that there into account. So we do like over the scale of the size of like a 7,500-meter square site, 50mm is relatively good. Like and the bulk that's being taken out of the ground. Again, it does. You need to take into their considerations if there has been any material imported on site. The likes of if a car was sitting on the site, points would be taken from the car, so you need to take that there out of your contours to accurately identify that there as well. So there's a lot of considerations. You know, it's interpreting data and not just straight up exporting it.
And tell me, in Felix O'Hare, sorry, Tara, I've cut across you there. How many drone pilots have you got, or do you have a champion in the company that is kind of saying, well, I'm Mr. Drone, I'm the main pilot here, or do you buy them in?
I would say that's myself. Yeah.
Is that you? Are you the main pilot there?
Yeah, we had 3 licensed pilots, so 3 of us went for our license exam. One has since previously left the company, but yeah. So because I'm digital construction, we have a QS as well. As a pilot, so if I'm off or I can't do a flight at a particular site, then he can go. But yeah, because I sort of go around sites, training as well in common data environment and laser scanning and just anything that is really on all our sites. I'm sort of best positioned for tying it all in together.
But I think it's a good example of something that started off was really quite kind of experimental. So, at the start of this project, we were looking at all sorts of different technology, and definitely over the course of the project, it's really proved its worth and it's become really part of the company's core business. So from something that's quite niche, it's now absolutely essential to the business.
Yeah, and it's interesting when Alain was talking about the supporting technologies. You saw one of his slides there. He had cloud, he had AI, he had robotics, he had AR, VR, drones. So as the future is that all these things need to talk to each other and work with each other. We got fixed cameras on sites, time-lapse cameras, we've got drones, we've got sensors. We have a project of our own starting very soon here in TU Dublin, which is a digital disruptive technology innovation fund with Evercam, Gaga Muller, where we're looking at using sort of camera technology and sensor technology to really monitor, health and safety and site progress and so on and so forth. But, drones must come part of that conversation as well. So thank you so much, everyone. How are we doing on time? I think we're now just 25 past. Okay, so Alain, back to you if I could. Thank you, Will, and thank you, Tara. Will this become, you mentioned the word framework. I keep hearing the term framework. For us to deliver the housing in Ireland, do we need a similar framework whereby, contractors and supply chain can work together to deliver the supply pipeline that's needed?
Yes, I think you mentioned you referred earlier to the investment the UK is making, and there is a clear business case. If you're delivering 35 billion of infrastructure and projects, and when I say infrastructure, I mean social infrastructure. It includes schools, student housing, etc. You've got a really clear business case. If I can improve that by 1%, what's 73 million in front of that? But then you have to look at it from a capacity point of view. I think we were talking about that earlier on. You know, factories need a stable demand.
Yeah.
And then you need to think about it in terms of supply network, because factories don't work in isolation. They have their suppliers, their supplier base. And so you really need to think in terms of supply network, supply chain network footprint. And that's really one of the things that we're working really closely with the automotive industry to understand how they analyze their supply chain network. They don't always get it right. You know,
no.
we are running out of cars at the moment because the
not enough chips.
Supplies, but that's a great example of showing what happens where, you know, if there is one, not just one chip, right, but it's the ability to make these silicon wafers, you know, if that is the central part that ultimately serves the overall demand, if you run out of this silicon wafer, you can't make chip, and then it gets prioritized. So you really need to think about it. Can you tap into other supply chain networks? So we're working with automotive manufacturer that says we can stamp metal, we can make configure to order, etc. And that's really, really exciting. But it requires a lot of work on, you know, value stream mapping and understanding.
So thank you very much. I mean, just a message to the delegates that are watching this stream. You know, a lot of the presentations today have been strategically selected due to, you know, because of the messages. You know, we're going to hear from Thomas Bach about robotics in construction. We're going to hear from A. Winfield about procurement and contracts. After the coffee break, we're going to hear more about modern methods and about, you know, sustainable, viable, volumetric construction. So I think I thoroughly enjoyed this session, despite the little bump we had on the way, but that's going to happen. That's always going to happen. And Willie did a fantastic job. Well done. And thank you, Tara. And thank you, Alain, again. I say it again. I hope the people watch that presentation because it is where we need to be. I think that's a wrap.
Thank you.
Thank you.
Thanks, Al.